Hi, I'm Everett. Welcome to the shop. This week I have a project I've been meaning to make for a while, and it's for the lathe. What's happening is I've been having trouble lately trying to part off parts or do deeper grooves on my lathe, and I have a suspicion it's because of the quick change tool post. I have a piston-style dovetail quick change tool post along the lines of the BXA series. It came with the lathe. But what I have noticed is at times I can actually watch, especially when parting or threading or doing deep grooves, I can actually watch and see the tip of the tool dig and pop down below center line a little bit. And I've had that happen a couple times where it actually hooked in and broke the tool bit, or a couple times actually spun the part right out of the, pulled the part out of the chuck. Kind of got scary a bit for that bit. So I have a suspicion I have some flex in that quick change tool post that I really don't want. It doesn't matter as much for straight turning or facing or other operations, but parting and grooving really seem to need a fair amount more rigidity. For that, what I've decided to do is, I know I could get a wedge style BXA tool post, but again, those are a fair amount of money, and I'm trying to save up for a few other things in the shop here. And so less working on that and more working on some of the other tooling I need. So what I've decided to do is, I'll give it a try anyway, is I got this piece out of a scrap metal bin a while back, and I'm not sure what type of material it is, done up on a CNC machine and then thrown in the bin. This actually will be about the right size for making a turret style tool holder. I like to make this a bit more rigid than the original tool post. We'll see how it works. For the fact it's a piece of scrap metal and it involves a bit of time, it's worth the experiment. I've already got a couple holes, or 4 holes drilled for the on the corners. I'm just going to add another couple holes first, and then thread those as well for the set screws to hold tools in. And if I want it being able to hold all 4 of my threading, grooving, and parting tools in here, great. If not, so be it. What I'll probably do is use to mark out the grooves I'm going to cut all the way around all 4 sides is the height gauge and some marking glue, and then just mark out the groove and just cut the groove all the way around. What I'm going to do is I'm going to clean up this face, just more for aesthetic purposes than anything. I think I'm going to clean this up to a nice round feature on the top, and then I'll drill it and drill it out to the same diameter as the bolt that I have going through the tool post already. And then what I'll probably wind up doing is I may have to make a spacer washer on top to allow the nut to suck down and tighten it up. I'm going to use the same tool post clamp bolt that the original tool post uses. So that guy there, I'm going to just take and we'll measure that portion there. So the widest portion here is 707 thou, which is pretty close to 18 millimeters. Being a metric tool post, that's not surprising. I don't know if I have an 18 millimeter drill bit. I'll have to see what I have that's close, and yeah, we'll have to go from there. If I have to bore it slightly, so be it. What I've done is I've indicated the part into the 4-jaw chuck, mounted the 4-jaw, indicated it in the 4-jaw chuck. And just to show you how it's set up here, as I rock the part back and forth, I'm trying to get the glare a little bit less harsh. Oh, here we go. Yeah, I would do it that way. You can see the needle, as I rock it, it stops in one position. I've zeroed there. What that is that's the lowest measurement I can get. As this, as the face turns, it starts pushing against the plunger. The lowest reading you get is the reading you take. So I'll pull this back gently. As you can see, it says about, well, a thou under there, but I also bumped it. Yeah, about a half thou under there. So I'm within a half thou. This side here, yeah, it says about a thou under there. A thou under there. We're within a half thou to a thou worth concentricity of the center line of the block to the center line of the spindle. which is plenty for this project. So now what we're going to do is we'll take and face up this surface here and turn this outer diameter, or turn this to a diameter. It's going to be interrupted cut, so it might be a little bit ugly sounding to start with. We'll try it at a fairly slow speed to start with, bringing it gently until it touches off. Oh, there we go, we're touching. We'll zero the hand wheel just for kicks and giggles. Take a 10th thou cut, see what she does. Maybe it can go a little bit faster. 10th thou. Twenty thou. Looks like I'm going to have to stick with 10 thousandths per cut. Now, as you can probably guess, after seeing the feature that was on the front there, raised feature, at 10 thou per pass, this is going to take a while. So what I think I'm going to do is I'm just going to keep carrying on like this. I'm going to pause the cameras. When I get right close to being circular, I'll bring you all back in. Well, as you can see, we're getting almost circular, so I'll bring you back in. Won't be too many more passes now, and we'll actually have a circular shape on the top of this, block. Again, I'm not entirely sure what this was supposed to be. It came out of, somebody gave me out of a scrap metal bin. A CNC shop. Got a couple more like it. Well, there we go. Now we're starting to see continuous, or a little bit longer chips. This diameter here is not critical. Just whatever looks nice. There we go. We are circular. Now let's face this surface here up. And we've got stringy chips. We'll slow it down a little bit and then take that burr off. Take the rough edge off the outside corner. That looks better. So now we have to center drill the center. Tail sock locked. Okay, our center drill is marked. We bring in a 1/4 inch drill bit as our pilot drill to go all the way through the block. Yeah, I think that's through. 11/16 drill bit. about you all watching, but for me it's just something really cool. It's watching metal peel never gets old. Ooh, looks like this one could use a regrind as well. There we go, we're through. So 69, 690. 690 is where we're at. We need to be about at 710, so we just need to take about 20 thou out of the middle of that. Okay, so it's touched off there. 5 thou. 5 thou radius makes 10 thou diameter. I'm only going to take 5 thou per pass. And if I do 2 passes, that should be 20 thou, which should get us close enough to our 709 thou or so. Okay. $700. Okay. Slow it down a bit. Here we go. Roughly 710, 711. Just slightly. There we go. Yeah, I will call that acceptable. We'll spin this piece off. There's the nut. Pop the post itself off. Oh, just like it was meant for it. That's a nice fit there. So how much of a height of a spacer am I going to need? Probably even, yeah, just an inch would do it. Because I'll probably use the regular nut, not my quick handle. I'll probably use the regular nut that came with the lathe for mounting this guy. So yeah, so if I make a sleeve about an inch high with whatever it is, 18mm hole, oh, 628, 624. So yeah, that's 5/8. All 4 sides of this block have now been blued. I also laid a little bit on the top here for when we lay out our lines for the tool holder set screws. I've set the height gauge to 500 thousandths or 1/2 inch. So now all we need to do is just take a scribe like that. Next step is, as I say, I figured I'd open it up 11/16 of it, make an 11/16 gap so I can fit my 5/8 tool holders in, because a lot of the tool holders I have are about 5/8. So that comes out to 1.1875. We're gonna go, so 0.1. Let that ratchet in. So that's 1.150. 1.875 according to the vernier scale here. There we go, 1.1875. Next step is, what I also did was I measured the diameter of the hole, which is 280 thousandths of an inch, roughly 7 millimeters. So each hole is roughly 7 millimeters, or 280 thousandths of an inch. The edge of the hole is 160 thousandths from the edge of the material. So you take 1/2 the diameter plus that, we wind up with a 300 thousandth of an inch center line to the hole. So for that, we'll bring our height gauge down. It's one of those things you could probably do with just a set of dial calipers, but once you actually have one of these things, it's really, really, really handy. What I did was I calculated out the spacing between the holes from here to here, or between the holes themselves, and then split the difference, and 953 thousandths, if we go 953 thousandths in, 953 thousandths in, they'll be spaced evenly. They'll be spaced evenly along. That's 950 plus the 300, so that's, so if it's 300 to the center line, 950, that would be 1253. So at each one of those intersections on the face there, I don't know if you can see it there, but each one of those intersections on the face is where the hole will have to go for each of the threaded holes for the set screws to hold the tools. One trick an older fellow showed me is, I don't smoke. However, I actually do keep a pack of cigarette rolling papers in my toolbox here, because I was shown one time about using the cigarette papers as a crude, well, rough form of edge finding. Now the thing is, if you take your cigarette paper, stick it up against your material, and as soon as it grabs and actually tears the paper slightly, getting close, this is not the end cap to a nuclear reactor, as John would say. Now the paper itself is about 1,000th thick. Yeah, I think that's getting close. There we go, just toward the paper. All four sides are getting cut the same. So what we can do is, that's our 0 mark. 5/8 and a half will be 1 1/8 inches. There's our edge, 1 inch 125. I'm going to zero my collar on my y-axis. Again, I also want to do at some point a digital readout on the quill, but that hasn't happened yet because I still need the time to do it. So I just touched off. Let's take a 20 thou depth of cut, just see how it works for now. Give a little drool of oil. That's actually cutting quite nicely. That's cutting really, really nicely. I like that. Now I know you all have stuff you want to do in life as well besides just watching videos on metal cutting, and I mean, I'm a bit of a metal peeling junkie myself. I love to see it curl off. But what I'm going to do here is I'm going to pause the camera, and when this groove gets closer to 625 or 5/8 depth of cut, or depth of the groove, I'll bring you back in for the final passes as I do that, and then clean up this one side. A bit of a change of plans. I wound up changing out to a 3/4 inch 2-flute end mill to help clear the chips a little better, and whatever, I'll go with the 3/4 inch slot instead of an 11/16. It gives me a bit more room to shim anyway as far as adjusting. We're now making the 600th thou pass. I've decided to go, I've been pushing it a little bit. I've been doing 50 thou passes. And so I'll do one more 50 thou and then a 25, and then we'll be down to our 5/8. I really have to get some form of misting set up here. What I've been doing is I just give it a little quick coat of oil, and hopefully some of it survives, and just run a little bit of compressed air to blow the chips away. Dial another 25 thousandths. That should be pretty close to 5/8 of an inch depth. Yeah, 626 and a half. I'll take it. So I'm going to hit this with the vacuum, clean this up, and then what I'll do is rotate it 90 degrees, touch off, carry on down, and I'll do that for all four sides. I can still keep my y-axis setting with the table because we're still cutting, and this it's going to be the same cut all the way around. So rather than have you have to watch me do every single pass, I'm going to pause the camera again and then bring you back in right when we're finishing up the last cut. Bingo! Let's quick double check, make sure before. Yeah. Clean the part up, deburr it, and now what we need to do is drill and tap the holes for mounting tools. What we're going to do is we're going to use I just put the 5/8 collet into the spindle, and we're going to use the little centering tool. We'll find the center of the hole right there. Now I can lock off the y-axis because we're only going to be moving in the x-axis. So now what I can do is I'm going to zero the collar on the x-axis, and according to the calculations, 953 thousandths is needed between the holes. I'm going to make a mark on the actual table edge so that I know when I've actually returned home, because I have my zero. Is the backlash taken up, trying to push this way. So now that we've found the location of the hole, what we need to do is we'll drill this one out to its final size, because I'm going to take all the holes out to a letter P drill, which is 323 thousandths. That's not a full 75% depth of thread, as far as the standard 5/16 drill bit size that you're supposed to use, but it's also not a 60, so it's somewhere in the middle, and I'd rather do that than break off another tap. I don't have any high-speed taps yet, so this is the best I'm going to be able to do. I have a chance to use the drill chuck tap handle. There you go. Tighten that up. You have a chance to use the drill chuck tap handle. Thanks again, Chris, for the idea. Yeah, she's starting to spin in the chuck now a little bit. after some of the fiascos I've had with threading. I'm very paranoid about this. There we go. I can see the tap coming through on the other side. Yay. There we are. One tapped hole. So next step is move the entire table this way 953 thousandths. It should come right down on that little spot. Yes, it does. Yeah, there we are. Yeah, we're through. We're at 953 thousandths, so we need to go to 1.906. There we go, 1.906. Lock off the x-axis. Spot drill that next hole. I have a number more holes to do here, but you see the basic idea of how I do them. So what I'll do is I'm just going to finish doing up all the holes, and I'll make sure I countersink that as well on my way back through. And then I'll bring you back in for pretty much the finished, close to the finished product. We still have to make the little sleeve for the top, but that'll be close to the finished product. On the last hole here, as I'm getting down the bottom, there we are, we're through. Hooray! Tell you, having this stop here, I just used the, like I say, one of the table clamps, finger clamps for setting up on the vise, and that just created my mill vise stop. Apart from a small amount of deburring, a little bit of cleanup. I have to take some solvent and get the blue or the marking compound off. At some point I might hit it with some cold blue, but for now I kind of like how it looks. I'm just so yeah, I'm going to pause it here, and then next step is I'll clean it up, but the next step is I have to make that little 1-inch riser block that goes off the top with a hole through the center. So we'll bring you back in at that point. Now this is 1 3/8 inches long, it's 2-inch round. My suspicion is it's probably 10/18, which will be just fine for our purposes. I'm just going to face both ends and drill a hole in it. If it winds up being 1 1/4 inches long, oh, there we go. If it winds up being 1 1/4 inches long, so be it. It's not going to hurt anything. Give it a nice chamfer. Flip it around. Again, it's okay if it's a little on the long side, it's not going to hurt anything. Oh. Spin it back up. spot drill. We're through. Just gonna do a quick little deburr with the Noga tool. Have to do the same with the back. Oh. Now I bring this nut out every now and then if I can't get the quick chain or quick release handle in underneath the chuck guard or something like that. If you give me a minute here, I'm just going to go grab a wrench so I can snug this down if necessary. I'm going to start spinning in the set screws, and then yeah, just for kicks and giggles before I call a night here, I may actually try parting something off. I'm not sure what grade of steel this is, but I'm not sure what alloy the steel is. So far it's cutting nicely. Actually, if this works as I hope. Oh yeah, that's much more solid than it was before. I still doubt this is some high strength alloy steel, but yeah, if it's going to part off like that, I'll take it. Nice. Alrighty, I'd say that's a success. I mean, this is something I've been meaning to make for a while, and what I'm hoping is that, again, this blade's a little on the too long side, so if I can use 3 to 4 different tools in here, that'll also free up some quick change tool holders for my other quick change tool post. Yes, it's a little bit longer to get set up, but yeah. And I realize some people may figure this is actually a step backwards, in that quick change tool posts are much quicker to set things up. I realize that. I would like to be able to afford a wedge type quick change tool post, but I can't. Not for, let's just put it this way. My wife has been very supportive of my hobby, and I just don't want to push it. As well, I don't want to be dipping into the diaper or formula fund in order to buy tools. So if I can make this for free out of a piece of scrap that I had, and yes, Pierre, I know it seems almost like it was tailor-made. Honestly, this is just how this piece came out of the scrap bin, was with the feature on top, and as you saw. Anybody can make one of these. It's not a big deal. This is not a complex project. All you'd have to do is square up your block first and fit, make the dimensions to your own lathe. Again, this is just farting around in my own garage, making things work that I need to. But yeah, this is something I've been meaning to do for a while, and hopefully I'll have better experiences with parting off parts in the future. So anyway, thanks for watching. Thanks for subscribing. I'll see you next week.